Here we have the formula for the variance, and here's the square root of that formula to calculate the standard deviation. Okay, we want to find the standard deviation of these 7 numbers. First we put them into a table. We add all the values of the 7 numbers together. Then we square each number and add all the squares together. First we then calculate the mean, the sum of all the x values divided by the number of values, which gives 4.571. Then we put this value together with the sum of the squares into the variance formula. So sigma x squared over n, 170 over n, minus the mean here, squared, gives me a value of 3.3877. We square root that, and that gives us our standard deviation to 3 significant figures. So now we will carry out a complete calculation for a frequency distribution. In this column we have values of x, the variable, and in this column the frequencies. So 4 occurred 4 times, 8 occurred twice, 12 occurred 3 times, 16 occurred once, and 20 occurred 3 times. Down here we have our formulas we discussed earlier, and to be able to substitute the summations into these formulas we must calculate all these values. So in this cell, this column here is f times x, so in this cell we have 4 times 4, and in this cell we have frequency 2 times 8, and in this cell 3 times 12, now in this column we have the frequency times the value of x squared. So for this cell here we have 4 times 4 squared, which is 64. In this cell here we have the frequency 2 times 8 squared, and so on. Now we calculate the summations. We add together all the values in each column. So in the frequency column the sum is 13. In the fx column the sum is 144. In the fx squared column the sum is 2080. Now all we have to do is substitute these values into our formulas. So first we calculate the mean, sigma fx 144 over sigma f13, which gives us 11.08. Down here on the standard deviation formula, sigma fx squared is 2080, sigma f is 13, and mu, the mean, will be 11.08, which gives us this expression, which we then evaluate, giving us our final result. Finally, we look at the situation where the values of x are in a grouped frequency table. This means that we know that, for example, 2 of the values of x are between 10 and anything up to 20. 3 of the values of x are between 20 but less than 30. 3 of the values of x are between 30 and less than 40, and so on. In this case, we don't know what the value of x actually is, so we estimate that these 2 values of x are at the midpoint of the interval, that is at 15. That these 3 values of x are at the midpoint of this interval, 25, and these 3 values of x are at the midpoint of this interval, and so on. There are no values of x in this 50 or more, so we can finish. To calculate f times x, we now multiply the frequency by the midpoint. So 2 times 15, 3 times 25, 3 times 35, 5 times 45, and then fx squared will be 2 times 15 squared, 2 times 225, which is 450, 3 times 25 squared, 3 times 625, 3 times 35 squared, 5 times 45 squared, and now we've completed the top part of the table. So now we need to work out the summations. So sigma f is 13, sigma fx, the sum of these numbers, is 435, sigma fx squared, the sum of these four numbers, gives me 16,125. We put these numbers into our formulas. The mean, sigma fx, 435, divided by sigma f, 13, gives a value of 33.46. Sigma fx squared, 16,125, divided by sigma f, 13, minus the mean squared, minus 33.46 squared, gives me 10.99.